Why would the US Space Force quietly slide a launch window? No fanfare, no detailed rationale, right as a once-in-a-lifetime interstellar object knifed through the inner solar system. Before you decide it's nothing, ask yourself this. If you ran America's most sensitive launch operations and a hyper-fast visitor from deep space showed up shedding debris, July 1st, 2025, the Atlas survey in Chile flagged a moving point of light sliding against the star field with the wrong speed, the wrong angle, and the wrong pedigree. Designation 3I/ATLAS, the third confirmed interstellar visitor in human history. Not a member of our local family, not following our traffic rules, moving at roughly 130,000 miles per hour on a retrograde path, which is shorthand for backwards compared to everything else. This is the kind of object that makes orbital dynamicists sit up straighter and mission planners audit every contingency plan they've ever written. On paper, it's just a comet. In practice, it's a live-fire test of everything we don't control. Interstellar bodies don't politely file flight plans. They don't move like belt asteroids. They arrive hot, fast, unannounced, and they shed material as sunlight warms them. Tiny grains, flecks, pebbles, each fragment turned by physics into a hypervelocity dart. On Earth, a chip of paint can pit a space station window. In orbit, a frozen marble at 130,000 miles per hour is a shotgun slug. Now line that up with an active launch corridor carrying $1 billion payload you can't replace. That's the nightmare. What most folks don't know is that Space Force doesn't just watch space, it models it. The Space Domain Awareness, SDA, network, ground radars, deep space sensors, telescopes, fused with predictive software, keeps a rolling map of what's aloft and what's inbound. When a true interstellar object pierces the heliosphere, SDA doesn't shrug. It runs trajectories, projects debris cones, and simulates collision probabilities across launch windows and orbital highways. Not as a science fair project, as national security homework. So, imagine April 2025. To the public, 3I/ATLAS is still a rumor in raw data. Inside SDA, it's already a set of vectors threaded through launch calendars, separation burns, and downrange corridors. Maybe the collision likelihood is low, maybe it's vanishingly small, but when the ticket price on your payload has 10 zeros and a stray pebble can cascade into a debris swarm, low is not the bar. You move the window, you call it range, you keep operational details off the record, and you watch who notices. There's a second reason you would nudge the clock: training value. Real interstellar targets don't come often. You can't schedule them for a Tuesday tabletop exercise. If you're serious about defending space infrastructure, you treat 3I/ATLAS like a pop quiz from the universe. You practice re-optimizing launch corridors against a live unknown. Skeptics will say, if it was safety, why not just say safety? Because admitting you're tuning launch windows against an interstellar object advertises how far your sensors reach, how quickly your models converge, and what low probability actually means on your internal scale. That's candy for adversaries. Better to tuck the adjustment into the usual basket, weather, range, and keep the telemetry and thresholds classified. Meanwhile, telescopes did what telescopes do. Hubble's July 21st imaging showed 3I/ATLAS waking up, coma swelling, tail forming, exactly the kind of activity that seeds a debris trail millions of miles long. ESO instruments saw the same. This isn't a movie trailer, it's a physics problem. Sublimation lifts fine grains off the nucleus, solar radiation pressure herds them into filaments. The solar wind sculpts the wake, and your launch corridor crosses the plane of that. One more uncomfortable thought. What if the object isn't the only variable? 3I/ATLAS is retrograde and fast, which means any liberated fragment has relative velocities that turn small errors into big misses. A debris packet you never saw can cross your path between go-no-go poles. If you've got the option to bias the window earlier or later to buy a few extra sigma of safety, a quiet launch nudge aligned with a hyper-fast, debris-shedding stranger. A military tracking network built to see around corners, using it as a live world drill. If you still think this was routine weather, say why in the comments. If you think the quiet shift was the smartest thing they could have done, say that too, because once you see how thin the margin can be,